Wannabe farmer here, showing you how our system, our heating control system is set up for my family in case they want to go check this out. Or I'm not here and they need to do some troubleshooting. Or somebody else comes along and needs to know how our system works. Our system has 4 zones, 2 transformers. Each transformer is fused and going to 2 of the zones. A quick way to check if you can't see whether or not your fuse is blown. Whoops, there, I hope I didn't break that one. So I'll put that fuse in there, but I'll leave it open just for demonstration purposes. Rather than pull it out and ohming using the ohm scale, you can tell while it's in place what's going on. You gonna listen to this, buddy? Okay. So what you do to check this fuse with this system is you place your black lead in common, your red lead in the V port over here. Over here is the amperage. We're not using that. We're not using that method. You turn your dial to V with a squiggly line. That squiggly line means you're measuring an AC voltage. You then come over here and make sure your transformer works first off. Your transformer is giving you a good voltage. That way you know transformer works, your meter's set up correctly. Then when you come over to the fuse block and you measure both sides of the fuse, I'm pulling it out so it's an open. If you have an open fuse or a burned out fuse, you will get the full applied voltage of 24.4, 24 to 26 volts. When the fuse makes that circuit, you will have just about nothing. You will have from 0 to 0.2, depending upon how much current's flowing through the system. If you want to know a little bit more, this is a resistor in effect. And if you have current flowing through it, you drop some of the voltage across the resistor, and you can use this as a current viewing resistor to measure the current in your system. But that's pretty simple, equals I times R. Again, I'm not a trained professional. I don't advocate you working on your own systems at home, but for my family, if we need to convey this information to somebody, I'm making this video. Now, here's a schematic of how the take-o valves should be wired in, showing the transformers. Here are the spare fuses. Now, what happens is from the transformer, the voltage goes out it's supposed to go out on the red line to the thermostat. Thermostat is an open and closed switch. We don't have fancy thermostats here. We have a mercury and the rest are digital, but it's an open and closed switch. Once that switch closes, it sends a signal back, and it should be coming in on the white wire back, but whoever wired this switched it around. It comes back and it comes in on a red, changes from white to red, and comes in on terminal 1 of your take-o valve, and that controls the take-o valve and causes the unit to slowly push this brass knob out and open up the flow valve or the control valve on your zone, and at the same time it presses another switch closed. I'm pretty sure it's closed, not an open. And when it does that, it makes terminals, yes, it's going to be closed, because it makes terminals 2 and 3 on the take-o valve. And on our system, it's a little screwy. It's white and green, and then it comes back here to this line and changes white to red, goes down here to our aquastat. We have, let me bring that down, show you the aquastat. There's the aquastat. Also, for my family, we have a spare aquastat right here. In case I'm not around and something goes wrong, don't let them sell you another one. Spare one right here. Same thing. 2 pins on the left, 2 take-o valve, and it says right there, thermostat, T and T. It's white and red. And it goes back to each one of the take-o valves. Each take-o valve comes in and is all tied together. Any one of those switches that make, any one of those take-o valves that pin 2 and 3 make, because this knob comes out and presses it, will turn on the aquastat, and that will turn on the circulator. I will show you that by just shorting out pin 2 and 3. Don't do this at home, folks. I'm not a... Did you hear the circulator go on? Okay, the take-o valve does the same thing by causing that little brass piece to push out. You heard the circulator go on. There's a little white wheel that rides on a cone, and that's driving the valve, the zone valve, open, so that when the circulator's on, that particular zone will be circulating the warm water and the other ones will be off. Or any other unit that is open, because a thermostat is that's getting confusing. Valve open because the thermostat is closed and supplying an electrical signal. Now, if something goes wrong and we lose the thermostat upstairs, you can pull with this mechanical lever, you can pull it forward and it pushes the zone valve so that it's open. The zone valve open, anytime the circulator's on, water will flow through that zone at that point. Think I covered everything? Want me to say it again? I'll go through it all again for you, buddy, so you'll know, because I'll keep explaining it and I'll have like 10 takes. And